Hi students, welcome to today's class. In this video, I am going to explain a very basic fundamental definitions of conic section. So altogether 8 definitions are there. So those who want to learn the subject in a fundamental way and a conceptual way, so you have to know all these fundamental definitions, not simply by hearting the concepts. These 8 fundamental definitions are applicable for any conic section. That may be a parabola, maybe hyperbola, maybe ellipse, or maybe whatever may be the conic section. These 8 fundamental definitions are very important. Okay? Right. So without wasting your valuable time, so I am straight away starting the class. So in this class, the first fundamental definition is principal axis of the conic. Simply axis of the conic. What is axis of the conic? Let us see that. So in the conic, already in the geometrical definition we have given. So let us take a fixed point S. That fixed point we are calling as a focus, and a fixed straight line we are taking. This fixed straight line is we are calling as directrix of the conic. This fixed point is called focus of the conic. This fixed line is called directrix of the conic. Okay, now right. Now principal axis or simply axis of the conic, whatever may be the conic, is it is a straight line passing through the focus and perpendicular to the directrix, passing through the focus. So there may be one directrix or two directrix, there may be one focus or two foci, but it should passes through the focus and should perpendicular to the directrix. That means, so it is a axis means, so this is called axis of the conic. Axis of the conic section. So axis of the conic section is a straight line passing through the focus or foci and perpendicular to the directrix or directrices, maybe two directrices. Okay. So that line is called principal axis or simply axis of the conic. Okay. So from this we can say that the directrix and axis are perpendicular to each other, and axis is always passes through focus. Okay, now right. I hope that you understand this definition. Let us go for second definition. The second definition is vertex or vertices. What is meant by vertex? First I will explain vertex, afterwards what is the vertices. So vertex means it is a point of intersection of the conic section and the axis. That means what? Let us see once again. So here S is a fixed point. We are already told S is a fixed point. We are calling it as a focus, and it is a fixed line. We are calling as a directrix. We are calling as a directrix. And we are calling is a line which passes through the focus and perpendicular to the directrix. We are calling it as a axis of the conic, or clearly if you want to say principal axis of the conic. Understand? Now vertex means whatever may be the conic. The point of intersection of the conic with the axis of the conic. That means, for example, this is a conic, section of the conic. It intersects the axis at A, therefore this point A is called vertex of the conic. If the conic intersects the axis at two points, that point is also called as a vertex. Understand it? Whatever may be the curve, maybe ellipse, maybe parabola, maybe hyperbola, maybe circle, whatever may be that, the point of intersection of the conic with the axis is called vertex. If one point is there, it intersects at one point, it is called a vertex. If it intersects at 2 points, it is called vertices. Understand? So we got the definition of vertex or vertices. Okay. I hope that you understand these two definitions. Let us see some more definitions. Welcome to two more definitions. These definitions are chord and focal chord. Chord means it is a line segment joining any 2 points on the conic is called chord of the conic. Already we have well aware of this word chord, where we use that word chord in circles. So if you take a circle, it is a line segment joining any 2 points on the circle is called a chord. Okay, already we know the definition. If the line segment passes through the center of the circle, the special name is given as a diameter. So diameter is also a chord, but what is the specialty of the diameter of the circle? It passes through the center of the circle. That's why it is called diameter. So the same concept apply here also. So what is the chord of a conic means? Let us take any conic. So it is a directrix and it is a focus. It is a focus. Let us take any conic, that may be a parabola, maybe a ellipse, maybe whatever may be that, any conic. Take any 2 points on the conic, any 2 points on the conic. So let us call it as a and it is call it as a B. So join AB. So this is called chord of the conic. Chord, CHO, or the chord of the conic. Such type of chords, how many we can draw? So we can draw infinite of chords, 1, 2, 3. So this is a chord, this is a chord, this is a chord, and this is a. This type of infinite number of chords are there. Understand? So all are chords. Chords means, so you have to take 2 points on the conic and you join that length segment is called a chord of the conic. Now what is focal chord? Focal chord, in name itself it is saying focal, focus, focus chord, focal chord. So any chord passing through the vertices, any chord passes through the vertices, just like there we are saying diameter, no? Just like we are diameter, we are saying no. This chord, a special chord which passes through the focus is called the focal chord. Any number of chords can pass through the focus. That means, see here, this is a focus, this is passing through focus, this is passing through focus, this is passing through focus. If you take the ellipse, it will have 2 focus. Here also passing through focus, passing through focus, passing through focus. All these are all called focal chords. Therefore, any chord passing through the focus is called focal chord of the conic. So any chord which is, a line segment joining any 2 points on the conic is called chord of the conic. A chord which passes through focus of the conic is called focal chord of the conic. Okay. So in general, focal chord we represent with the P, S, P dash. Generally, in general. So other letters also we can use, but in general, P, S, P dash. These 3 letters generally we use to represent the focal chord. Okay. So I hope that you understand these 2 definitions, that is a chord and focal chord. Let us see 2 more definitions. Welcome to 2 more definitions, very, very important. So one is a double ordinate lattice rectum of the conic. I am not specifically defining these definitions for particularly a parabola or ellipse or a hyperbola. So these are all applicable for any conic, any conic section. Okay, now, so see this double ordinate. What is double ordinate? So I will explain using some graph. Okay, let us take this fixed line, we are calling it as a directrix, and this fixed point we call it as a focus, and this line passing through the focus and perpendicular to the directrix is called a, we are calling it as a axis or principal axis. So let us take any conic, so sorry, this is a conic. Now he is asking the chord passing through a point P of the conic on the conic and perpendicular to the axis of the conic is called the double ordinate. So here any point, take any point on the conic. So P is any point P. So the point, the chord should passes through the point P and it should be perpendicular to the axis. So this is the axis of the conic. So any point, any chord, some PQ, we call it as a PQ, any chord passing through the point P and perpendicular to the axis is called double ordinate of the point P, or simply we call it as a double ordinate. So how many double ordinates we can get? We will get infinite number of double ordinates. So this is a double ordinate, double ordinate, double ordinate, double ordinate. So all are perpendicular to the axis of the conic. All are perpendicular to the axis of the conic. And we can say one thing, when this double ordinate is perpendicular to the axis, so the same double ordinate is parallel to the directrix. So this double ordinate is parallel to the directrix of the conic. So we remember that. That means the equation of the directrix and double ordinate differ by a constant term. So since they are both are parallel to each other. Okay. So that means all the line segments, all the chords which are perpendicular to the axis are called double ordinates. Okay. So if you observe in these double ordinates, one of the double ordinate passes through the focus, no, something special, definitely passes. One and only one thing, not too many. Only one line is passes, one double ordinate passes through the focus and it is perpendicular to the axis. That double ordinate is given a special name. That name is called latus rectum. Any conic. That means it is a directrix, okay, and it is the axis, okay now, and it is a focus, yes, focus. Right, it is a conic, whatever may be the conic. So a double ordinate passing through the focus and perpendicular to the axis is called latus rectum. Remember that the latus rectum and the directrix both are parallel to each other. The latus rectum and double, why? Because directrix is also perpendicular to the axis and a double ordinate also perpendicular to the axis, and moreover latus rectum is also perpendicular to the axis. Okay na? So that's why, so if you know the equation of the directrix, it is a very easy to find out the equation of the latus rectum. Understand why? Both together, for example, the point of this focus is some -2, 3. And the equation of the directrix is some 2x minus 3y plus 5 is equal to 0. So if you are asked to find out the equation of the latus rectum, so we can easily say that, so the equation of this latus rectum is 2x minus 3y plus k is equal to 0. Why? Because these two lines are parallel to each other and their equations are differ by constant term only. Then how to find out that constant term? So it is a known fact that all the latus rectum, so all, not also, only this latus rectum passes through the focus -2, 3. Substitute here -2, 3, you will get k value. Again you substitute k value here, you will get the equation of the latus rectum. Okay now? So very, very interesting topics. This is a double ordinate, latus rectum. So both together almost same. Why? Because all latus rectums are double ordinates, but all double ordinates need not be latus rectums. Okay. I hope that you understand these two definitions. So let us see some more definitions. Welcome back to this definition. Focal distance, name itself it is saying focal distance, focus. Focal means focus. The distance from focus to any point on a conic is called focal distance. So let us see the conic here. So this is a directrix and it is a fixed point is called a focus. Fixed point is called a focus. Any line passing through the focus and perpendicular to the directrix is called axis. This is the axis of the conic. Let us take any conic, whatever may be that. So let us take any conic. This may be a parabola, maybe ellipse, maybe whatever may be that. Any conic. Conic means a curve. So on the curve there are infinite number of points will be there. Infinite number of points will be there. Let us take any point of P, that is the distance from the focus to that point. This SP is called focal distance. Focal distance, wherever may be the point. So focal distance. For example, if it is a vertex, then SA is called focal distance. If this point is a SQ is the focal distance. If your point is some B, SB is the focal distance. Okay, if your point is some C, SC is the focal distance. That's the point, any point on the conic, the point should be on the conic to the focus is called focal distance. Okay, now, right. Very, very important one note point is here. The note point is for any conic, if semi-latus rectum is L. So here one word is came, semi-latus rectum. Semi-latus rectum means what? Semi means what? Half. Semi means what? Half. The length already we discussed what is a latus rectum. Semi-latus rectum means half of the latus rectum is its length is L and the perpendicular distance from focus to the directrix is D and E is the eccentricity of the conic. Then the relation between L, D, E is L by D is equal to E. Okay, I will explain using a diagrammatically. Okay, right. So let us take a fixed line. So this is the directrix. So fixed line is the directrix and this fixed point is the focus. This is the focus. Let us take any conic. This is the axis of the conic. Let us take the latus rectum. So latus rectum is a focal chord. We can say that latus rectum is a focal chord perpendicular to the axis. So one more definition also we can get. So latus rectum definition. Latus rectum definition is also a focal chord which is perpendicular to the axis. Okay. Now there is take a latus rectum. So this is the latus rectum. So it is passes through the S focus and perpendicular to the axis. Let the semi-latus rectum means half of the latus rectum. So from whatever may be the length, half of that length. Okay. So let this length be L. Semi-latus rectum length is L. And the perpendicular from focus to the directrix is D. That means from focus to this directrix, this length is equal to D. The semi-latus rectum length is L and the perpendicular distance from focus to the directrix, that means the perpendicular distance D, then L by D, the ratio of L upon D gives the eccentricity of the conic. Already we explained what is eccentricity. That means half of the latus rectum divided by distance between the focus to the directrix always gives the eccentricity of that conic. Okay. I hope that you understand this point. So this will be useful. So wherever if you want to solve the problems, this result. Okay, now, right. So let us see some more definitions. Welcome to this definition here. The center of the conic. What is the center of the conic? Already we know the definition of center of the circle we know. So what is the center of the conic means? Center of the circle means, let us see here. First, before explaining this center of the conic, let me explain what is center of a circle. Let us take a circle here. What is the center means? What is the center? So, center is a point which bisects every chord passing through it. That means, if you take a chord here, it is a chord, it is a point which bisects. Bisects means making it into two halves. Let us take another chord passing through it, it is also bisecting. Let us take another chord, another chord, another chord, another chord. So, it is bisecting the chord passing through it, that is called center of the circle. Okay. So, same definition applies for conic, any conic. The point which bisects every chord of the conic passing through it is called center of the conic. In place of conic, if you put the circle, the definition of the center of the circle will come. Okay. So, I will explain here. Let us take any conic. So, it is a fixed line and it is a fixed point, and there is a this is a directrix and it is a conic, whatever may be that conic, maybe parabola, hyperbola, ellipse, any line, any chord. So, I have taking one chord. Let this point, so I am not taking here, yes. So, here it is a point, it is bisecting. Okay. Let us take another chord. So, this is a chord, it is also bisecting. It's maybe if the diagram may not be accurate. Okay, chord. So, there is another chord passing to it, it is also bisecting. There is another chord, it is also bisecting. That means, any chord passing through this point bisects the chord passing through it. The point bisects the chord, any chord passing through it. So, that point is called the center. He is saying the center. That means, for every conic there will be one and only one center. Understand? So, this is called the center of the conic. Okay, now. So, I hope that you understand this definition. Now, coming to this, how to find out the center of the conic. So, for example, given the equation of the conics, it is a general second degree equation. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Then its center is given by hf minus bg by ab minus h square, gh minus af by ab minus h square. So, if you apply all the coefficients into substitute here, you will get center of the conic. Okay. Of course, here in the AB should not be equal to h square y because it is in the denominator. Okay, now, right. So, these are the fundamental definitions of the this any conic. So, I hope that you enjoyed today's all these 8 definitions, and tomorrow's class we are going to switch on to the chapter a special type of conic, that is parabola. Okay. So, you will get definitions of problems from the parabola, ellipse, hyperbola in your JEE MAINS examination. So, from the beginning every topic I will explain in detailed way. So, do not skip the videos every day, you please watch the videos. Okay, now, I hope that you enjoyed today's class. So, let us with some more definitions from chapter parabola. Tomorrow's class we will meet. So, until then, all the best.